Hello everyone, today we'll be solving question number 17 of NEST 2025 exam. The question says monochromatic light from a discharge tube containing dilute gas of hydrogen atoms falls on platinum metal which has a work function of 5.65 electron volt. The energy of the fastest photoelectron is 6.45 electron volt. This correspond to and the following options. We'll check the options, but before that, just understand the question. The question says, I have a metal surface. On that metal surface, a monochromatic light is falling. Now, work function of this metal surface phi is given as 5.65 electron volt. Ejected photoelectron has kinetic energy of 6.45 electron volt. So now by Einstein photoelectric effect, we know that net incident energy E is equal to the kinetic energy of emitted electron plus the work function of the metal. So net energy of the incident photon of monochromatic light is kinetic energy of electron, that is 6.45 electron volt plus 5.65 electron volt. That means that incident energy is equal to 5 plus 5, it's 10, 11, 12.1 electron volt. Now, this correspond to which of these following options? Now we have to check each and individual options, and based on that we have to calculate which is the correct option. So first of all, let's check the electronic transition. Okay. Now, formula to calculate the energy of electronic transition is E is equal to minus 13.6 into 1 upon initial state from where it jumped, that is, or the it jumped from 2 to 1. Okay, so 1 upon n final, that is 2 square 4 minus 1 upon n initial, that is 1 EV. So on solving this, we get the value as this is 4, and it's equal to 1 minus 4. Sorry, I said final is 1, initial is 2. So that means the final will be 1 and initial will be 4. So this gives 3 by 4. Okay. Based on this, the energy will come out to be 13.6 divided by 4. 3.4 into 3. That means 10.2. 10.2 will be the energy of the or the photon emitted when this transition happens. But it says 12.10. That means this it must be greater than this. Now let's check the second one. For the second part, the electron makes a transition from 5. The final is 2, that is n final square, that is 2 into 2, that is 4, minus 1 upon n initial square, that is 5. 5 square is 25. Now on solving this, we get 25 and 4. Common is, let's say, 100. 25 into 4 is 100, and 4 into 25 is 100. Here we get minus 13.6 into this, that is equal to minus 13.6 into 21 by 100. It is minus 28.5 electron volt. This is much greater. We just need 12. 0.1 electron volt. So let's check little higher than this. Here it was making transition from 2 to 1. Now let's check from 3 to 1. Okay, energy for making a transition from 3 to 1, that is 1 upon initial is 1 and final is 3, that is 3 into 3, that is 9. So on solving this we get minus 13.6, 9 minus 1 by 9, that is 8 by 9, and on solving this we get the energy as uh, 13.8 into 6 by 9 is minus 12.1 electron volt exactly. So now we know for which transition it is emitting this much energy. Okay, that means option 2 and 3 are rejected out. We have to now check the angular momentum. Now for angular momentum we know that angular momentum must be integral multiple of nh cut, nh by pi. Okay, nh by 2 pi. The angular momentum L must be integral multiple of this, where n is varying as 1, 2, 3. Now for the initial state L initial is 3, that means 3h by 2 pi, and final is 1h by 2 pi, as the electron had made a transition from third to first, 3 to first, due to which this much energy has been released. That means the change in angular momentum delta L is equal to 3 minus 1 into h by 2 pi, that is equal to 2h by 2 pi, that is h by pi. Hence option 1 is the correct answer. Hope you understand this question. Thank you.